Today we're doing section 4.1, day 2, and we're talking about how to graph angles in standard position. So there's two types of angles. There's positive angles and there's negative angles. So a positive angle travels counterclockwise, where a negative angle travels clockwise. Regardless if it's positive or negative, they both have 0 in the same spot. Pi is where 180 degrees would fall. So if I traveled 180 degrees, it would be located right here. So halfway between these two would be half of a pi. Then following with that rotation, each quadrant represents a half of a pi. And then we ultimately end up at 2 pi. And I could keep going around and around with this pattern of adding a half pi. Same thing is true for negative angles. It's just everything is in the opposite order. Notice negative pi falls in the same place because if I go 180 degrees clockwise versus counterclockwise, I end up in the same spot. So some terminology. You will have two parts, or kind of three parts to the angle. So this right here is what we call the initial side of an angle. And then wherever the angle ends up, let's just say it's there, that's what we call the terminal side of an angle. And then the last part of it is, well, how did it travel? So the angle could travel in the positive direction, or the angle could travel in the negative direction. So you always have to do that part to indicate which way the angle traveled. So in terms of the basic setup for positive, and this is true for positive or negative angle, I should have that both there. You're going to use the denominator of the given angle. And you're going to get common denominators at pi, which is 1 pi over 1. Then you're going to cut in half to determine each quadrant. And this will make more sense when we do an example. So again, graphing angles is going to be different for every single problem because the denominator could be different for every single problem. So for our first example, notice the denominator is 4. So I'm going to go over to here where it's pi. We know it's 1 pi over 1. And I'm going to make this be 4 pi over 4. And then I'm going to cut it in half. So halfway between 0 and 4 pi over 4 is 2 pi over 4. So now I've determined that each quadrant is going to go up in increments of 2 pi over 4. So I have 2 pi over 4, 4 pi over 4, which means that this is 6 pi over 4, and over here would be 8 pi over 4. So notice I was trying to graph a 1 pi over 4, so 1 pi over 4 is going to fall in the first quadrant, dead smack in the middle, and the way the angle traveled was in a positive direction. So not too bad. Let's try the second one. So again, our denominator is a 4, so I know that this is 4 pi over 4. I know this is 0, and I know this is 2 pi over 4, and I know down here is 6 pi over 4. So 5 pi over 4 is going to fall in quadrant 3, dead smack in the middle between 4 and 6. And the way, here's my initial side, I forgot to do the initial side over there. The way the angle traveled is from the initial side, and then it traveled counterclockwise to where it ends at the terminal side. All right, one last one, and we're going to talk about a negative angle this time. So notice the denominator is now 6. So I'm going to go over here and make this be 6 pi over 6. Halfway between 0 and 6 would be 3 pi over 6. So that means each quadrant is going increments of 3. So that means down here is 9 pi over 6. And over here is 12. Oh man, I messed up. So the reason I messed up is because this is a negative angle. So these should be switched. So this is a negative. So not a terrible mistake. Just don't do that on the test. Here's a negative 12 pi over 6. All right, so now that I have it kind of laid out, I got to graph it. There's that negative. So negative 5 pi over 6 will be in quadrant 3. So notice I have a negative 3 and a negative 6. So this would be like where my 4 is. This would be where the 5 is. So the 5 is going to be closer to the y-axis. Here's my initial side. And the way the angle traveled was in the negative direction. All right, so that's all for today. This should be a quick review because we did do this in Algebra 2.